So exercise 3 here and exercise 4 here both ask us to use the turtle bar chart program that we saw in chapter 5. So they helpfully link to it down here in exercise 4 here. If you go to that link there, you'll be able to get this code, which is the turtle bar chart code from last chapter. So we have this right here. Now, question 3. So before we get started, make sure that you take the time to read through this and make sure you understand how this program that we read in last chapter works. And if you don't understand, the page that this links to describes how it works. So it should be pretty familiar. Okay, so the question asks us to modify this program so that if any bar reaches above 200, then we need to fill it in with red. But if it's between 100 inclusive and 200 exclusive, it's filled in with yellow. And if it's less than 100, it's filled in with green. So let's do exactly that. So in our main function, we have the fill color listed right here. So if we run this now, we can see that it always fills in with red. So we're going to want to probably take that out of the main function here and put it inside of our drawbar function, because the drawbar function does the filling for us. So we want to be able to just put that in there and have drawbar do that explicitly. We could also write a different program that calls drawbar if we wanted to, and have a different program called draw colored bar or draw value bar or something like that, so that we don't have to mess around with the base drawbar program here. But in this case, we'll just mess around with the base drawbar. So we'll take out the fill color here and not set that to red, but we will come up here and just very simply, all we need to do for this, our pseudocode, is going to be check height, which is the value that we're passing in here from the data. So the bar height, the height of the bar, the value of the bar, check height, and adjust colors if greater than 200, less than 200, and greater than or equal to 100, or less than 100. So that's what we need to do, and we need to do it before we begin filling in, because we need to have the turtle have a color set for its fill color before it begins filling. So we'll use t as our turtle object because that is the variable passed in from the function here, and we'll set the fill color equal to red. So when do we want it to be red? Well, we want it to be red if the value is more than 200. So we'll simply check if height is greater than 200, sorry, greater than or equal to 200 because they want us to do 200 or more, then just set t fill color to red. Else, if height is greater than or equal to 100, then we'll set the fill color to, yellow. And then else, set the fill color to green. Now, if you're confused why we are doing it this way rather than just writing separate if statements, we're doing it this way because we want the logic to flow from one statement to the next statement in this case, because we're checking for a range of numbers, essentially. We're checking where it falls on the spectrum between 200 or more and less than 100. So there are cases where you could conceivably want to write just separate if statements, but if we wrote separate if statements here, so example, if I change this to if height is less than 100, what's going to happen is as it goes through the program, it'll check, is the height greater than or equal to 200? And then it'll say, okay, it is, so I'll change the fill color to yellow. Then I'll get down to the next one and check, is it greater than or equal to 100? Well, if it was bigger than 200, so say our value is 240, it passes true for this, so it changes the fill color to red. And then it also passes true for this, so it changes the fill color immediately to yellow. But if we have it do an else if, what happens is that the logic then becomes, if it passes true for this, it does not even test the else statement here. It doesn't test the else if statement down below. So always be careful when you're thinking out the logic for your Boolean expressions when you need to use them. Make sure that you're always thinking it through and trying to think, is this going to work in the way that I expect it to? Is it going to go through these statements in the way I expect it to? And oftentimes you will just want to pick some test case to try to test around your various things. So test bigger than you're expecting, test lower than you're expecting, test the middle cases. So what happens if it's exactly 100, for example. So test those first. To make sure that you have your logic flowing correctly. So that's all we should need to do here. So let's run it and see if it works. So that's green, 48 checks out, 117 checks out for yellow, 200 checks out for red, that's what we wanted, 240 for red, good, 160 yellow, makes sense, 260 red, and 220 red. Awesome. Yep, works perfectly. Down here below in exercise number 4, it asks us, what do we expect if one or more of the data values in the list is negative? So what do we expect to happen, right? If we pass in one of these as a negative data value, what do you expect to happen? Think about our logic here. Go through here with a negative number and see what's going to happen just using a negative example and just kind of following through in your head, follow the logic here and see what you expect to happen. What we'll do is I'll just go ahead and change one of these to negative here in the data set. I'll do the first one just so we don't have to wait too long to see it. And then I'll run it. So you can see what happens here. It goes negative and it goes green, which we expect because it's less than 100. And so when it's less than 100, we expect it to be green. Then they want us to go back and try it out. We did. So they want to change the program so that when it prints the text value for negative bars, it puts the text above the base of the bar. So it wants us to put the text on the 0 axis here when it's negative. Well, that's simple, right? We can do that same check within here. So instead, let's change this to elif height is greater than 0 because we want it to still be else if, because we want it to not activate if it fills one of these two, because if it fills one of these two, it makes no sense to activate this statement down here. So we'll have it elif height is greater than 0, and then down below we'll have it do else. We'll set the T fill color. What can we set it to? Let's set it to black. In this case, the problem specifications don't tell us to change it, but I'll change it anyway since we're going to do it anyway. So we, by their specifications, would want to do it to set it to green, but I'm just going to set it to black. And then while I'm here, I'm going to change the write function here. So I want it to write something above where we have the axis here. So they're writing a height at the turtle. So if I want him to write at 0, I need to set it so where if I want him to write at 0 right here, I'll have to set him to write before he starts drawing the bar, which is going to be a little awkward. So let me try this. So rather than do this, I was going to try to take care of it within that section of my function, but apparently it doesn't make any sense to do so. And that'll happen from time to time. You'll come across something and think, oh, I know immediately how to do this, and then not really. So really, I want him to write. So whenever you have a turtle write, he begins writing exactly where he is. So in this case, our turtle writes when he gets to the top of the axis, or the top of the bar, or in this case it would be the bottom of the bar when he goes negative. So if he goes negative, we don't want him to do that. We want to, if height is below 0, we want instead him to just write the height right here before he goes anywhere. That way he writes it right at the origin, right at the 0 of the axis. So we'll have him write it there. And if height is greater than 0, he'll write it above the bar. So if we run it now, we get the -48 right here, and then normal functions up above. So there we go.